will be explaining why Homer's equation is incorrect without actually evaluating the numbers. So the numbers I will be using today is 3,987 to the power of 12 plus 4,365 to the power of 12 equals 4,472 to the power of 12. For starters, we need to look at 3,987 to the power of 12, which we know is divisible by 3. We need to prove this though. So we know the first step that we need to do is we need to add these numbers together. So we've got 3 plus 9 plus 8 plus 7 equals 27. We know that 3 times 9 equals 27. So this proves our fact that 3,987 to the power of 12 is divisible by 3. Secondly, 3,987 times by 12 times 12 times will give us the number 1.61344,761. We know that this is still divisible by 3. So this proves our point. Secondly, 4,365 to the power of 12 we know is divisible by 3. To prove this, we need to do the same steps again. So we're going to add these numbers together. So 4 plus 3 plus 6 plus 5 equals 18. We know that 3 times 6 equals 18. So this proves our point that 4,365 to the power of 12 is divisible by 3. Secondly, if we took 4,365 and we times it 12 times, we would get a number of 4.7842182, which we know is still divisible by 3. So we can prove that 4,365 to the power of 12 is divisible by 3. Thirdly, 4,472 to the power of 12 isn't divisible by 3. So to prove this, we need to do our steps again. Step 1, 4 plus 4 plus 7 plus 2 equals 26. We know that no 3 can go into 26. So this does not pass our test. Secondly, 4,472, if we times that 12 times, the number we would get is 6.376656, and we know that this isn't divisible by 3. So we have proved that 4,472 to the power of 12 isn't divisible by 3. In summary, we know that the first step, 3,987 to the power of 12, must contain a factor of 3 because 3,987 does. Secondly, 4,365 to the power of 12 must contain a factor of 3 because 4,365 does. Thirdly, theorem says 3,987 to the power of 12 plus 4,365 to the power of 12 must have a factor of 3. Fourthly, however, 4,492 does not have a factor of 3, so the equation cannot be true.